Hello, I am Omnath Sharma and I am going to start my presentation on my assignment topic, that is Z transform. And here is the content. I had an introduction, definition, historical development, some standard Z transform, properties of Z transform, example based on Z transform, two basic theorem, convolution theorem, convergence of Z transform, evaluation of inverse Z transform with examples, and application to difference equation with examples. At firstly, now I start with the introduction and definition of Z transform. Z transform plays an important role in discrete analysis and may be seen as a discrete analog of Laplace transform. The role of Z transform in discrete analysis is the almost same as that of the Laplace and Fourier transform in continuous system. However, the main difference between them is the Z transform operates not only on functions of continuous argument but on a sequence of discrete integer valued argument. The discrete system is expressible as a difference equation and its solutions are formed using Z transform. Normally, Z transform solve the difference equation, very helpful to solve the equation. And definition: if the function un is defined for discrete value, that is n equals to 1, 2, 3, and if un equals to 0 for n less than 0, then the Z transform is defined to be z of un, that is the function un, which is equals to uz. Z transform is denoted by u of z, which is equals to summation of n equals to 0 to infinity u n z to the power minus n, where the infinite series convergence. And if we insert a particular complex number, if we insert a complex number z into this equation 1, then this z of un will be the complex number. Then the whole equation 1 will be of complex number. Thus the Z transform uz is a complex function. This Z of un, thus the Z transform uz is a complex valued function of the complex variable z. And it is the historical development which I had done. And some standard Z transform. The application of the definition, that is the equation, that is the application of the Z transform, that is z of un equals to summation of n equals to 0 to infinity un z to the power minus n, gives the following result. And first result is z to the power of n equals to z by z minus a. And if we prove, then proof by definition. Definition of Z transform, in place of un here, in place of un we have a to the power n. So putting a to the power of n, we get summation of n equals to 0 to infinity a to the power n z to the power minus n. When we split this, then we get the resulting value, that is 1. When we put n equals to 0, then we get 1. Similarly, when we put n equals to 1, then we will get a by z. After doing this, we will get the resulting value. We get the resulting value, that is z by z minus a. And here is the another result. Properties of Z transform. Linearity property. If a, b, c be any constant and un, bn be the discrete function, if un and bn are discrete functions, the z of a un plus b bn minus c wn, which is equals to a z of un plus b z of bn minus c z of wn. Linearity. This shows the linearity. I had done proof. Another one is damping rule. I had done some standard results based on damping rule. Another one is shifting property, right shift property and left shift property, with proof. Shifting, if the right shift property, if z of un equals to uz, then z of un plus k equals to z to the power of minus of k u of z, which is right shift. And another one, if z of un equals to u of z, then z of un plus k equals to z of k uz minus u naught minus un z to the minus 1 minus u2 z to the power of minus 2 dot 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 u of k minus 1 z to the power of k minus 1, which is left shift property of. An example based on z transform. First example, find the z transform of the following unit impulse sequence, del n equals to this, and discrete unit step sequence un equals to this. We will now prove why. We now prove why using the definition of z transform. In here del n, in place of un we will put del n, which is equals to summation of n equals to 0 to infinity del n z to the power minus n. When we when n equals to 0, then the value is 1, and n not equal, and other is 0. So here 1 and other is 0, so we'll get answer is 1. Second, z of un equals to summation z of un, which is summation of n equals to 0 to infinity un z to the power minus n. Where when n greater than or equals to 0, then the value is 1. So here un value is 1, so only z to the power of n, that is which is equal to summation of n equals to 0 to infinity 1 by z to the power of n. When we split this, then we will get the value, that is z by z minus 1. And this is another example. I had covered 4 examples of z transform. Then the two basic theorem were initial value theorem and the final value theorem. I had done with the, if z of un equals to u of z, then u naught which is equals to summation of u naught, which is equals to limit z tends to infinity u of z. This is initial value theorem. I had done with proof. And another one is final value theorem. That is, if z of un equals to u of z, then limit z tends to infinity un, which is equals to limit z tends to 1 z minus 1 u of z. I had done with proof. And I had done another, and I had done example based on these two example using initial value and final value theorem. Another one is convolution theorem. If z to the z inverse of u of z equals to un, and z inverse of v of z equals to vn, then z inverse of uz minus vz, summation of m equals to 0 to infinity um dot vn, which is equals to un e star vn, where the symbol e star is the convolution operation. Symbol e star denotes the convolution operation. And I had done with proof and example using convolution theorem to evaluate this. Convergence of Z transform, that is one-sided Z transform and two-sided Z transform with complete details I had done here. Another one is evaluation of inverse Z transform. We obtain the inverse Z transform using this three method, that is power series method, done with example. Another one is partial fraction method, and another one is inversion integral method. I done with examples. And application to difference equation, that is Z transform solve the differential equation which is Z transform is also very helpful to solve the difference equation. So here is the working procedure and examples to solve the difference equation by using Z transform. I had done uh, two examples. This much. Thank you so much.